There are two main types of pump substructures: a steel beam substructure and a reinforced concrete platform substructure. When a pump is mounted on a steel beam substructure, its baseplate can either be bolted or welded to the steel beams. The beams must be massive enough to rigidly support the pump and prevent any significant flexing of the pump's baseplate during the operation of the pump. Steel beam substructures are primarily used in pump installations, on ships, oil platforms, and the upper floors of steel frame buildings. A platform of concrete is the preferred foundation for fixed land-based pump installations. The raised foundation addresses some of the considerations for pump location, including protection from flooding and providing for moisture control and drainage. The weight and rigidity of the foundation also helps prevent any shifting of the pump's baseplate that can cause pump driver misalignment. The main steps, which will be described next, for installing a concrete platform, are: 1. Building the platform. 2. Preparing the platform for baseplate installation. 3. Preparing the baseplate for installation. 4. Installation of the baseplate. 5. Checking footpads levels and alignment. There are 5 main steps in building the concrete platform over which the pump's baseplate will rest. They are: 1. Determine the dimensions of the platform. 2. Install the rebar cage. 3. Set the anchor bolts. 4. Set the anchor bolt sleeves. 5. Pour the concrete platform. The first step for building a concrete platform for a pump installation is determining the required dimensions of the platform. Those dimensions can usually be obtained through the pump manufacturer. There are, however, some general rules that apply to the platform's dimensions. For centrifugal pumps, the mass of the platform should be at least 3 times the mass of the pumping unit, which includes the pump, driver, baseplate, and gear reducer if it is used. The platform width should be 1.5 times or greater than its height. In the second step for building the concrete platform, the rebar cage over which the concrete platform will be poured is installed according to the pump manufacturer's specifications. In the next step, the baseplate's anchor bolts are set in their locations based upon the baseplate's drawings. Use bolts with the diameter that is recommended by the baseplate's manufacturer. Make sure the anchor bolts have enough projection above the platform to hold the baseplate with the anchor nuts. Furthermore, the length of the anchor bolts should be at least 20 times their diameter. Pipe sleeves are then placed over the anchor bolts. The sleeves allow for thermal expansion of the anchor bolts without a lot of thermal fatigue. The diameter of the sleeves should be 2 to 3 times the diameter of the anchor bolts. This allows the sleeves to accommodate minor adjustments in the locations of the anchor bolts in order to correctly position the bolts with respect to the baseplate. This serves to minimize the effects of errors in the baseplate's hole layout, as well as any slight shifting of the positions of the anchor bolts during the pouring of the foundation platform. The length of the sleeves should be around 10 times the diameter of the anchor bolts. A sealant such as silicone should be applied to the top and bottom of the sleeves in order to prevent cement and grout from filling the space between the sleeves and the anchor bolts during the construction of the platform or the installation of the baseplate. The final step in building the pump's concrete platform is pouring the concrete. Before the concrete is poured, plastic or wooden forms should be put in place around the rebar cage to govern the flow of concrete into its final shape. The concrete mixture is then prepared by mixing cement, water, sand, gravel, and any required additives as recommended by the concrete manufacturer. The concrete is then poured into the forms. Care should be taken while pouring the concrete in order not to shift the position of any of the anchor bolts. Before installing the pump, the concrete should be allowed to fully cure. This is due to the fact that as the concrete cures, it can shrink. The shrinkage of the concrete platform can cause the base plate to shift if it is installed prematurely. Regular concrete requires 28 days to fully cure, while quick-setting concrete requires 7 days. Before installing the pump's base plate on the concrete platform, several steps need to be taken to prepare the surface of the platform. The top surface layer of the platform must be chipped away. This layer, which is known as laitunce, is made up primarily of cement and is much weaker than the core of the concrete platform that contains the coarse aggregate particles. The surface should be chipped until the coarse aggregate core of the concrete platform is revealed. This is done usually using a pneumatic chipping hammer. The final surface should be reasonably flat and level. The top outside edges of the platform should be beveled at a 45-degree angle. The top surface of the pedestal should be thoroughly cleaned to ensure it is free of oil, grease, and loose particles. Depending on the type of grout that will be used to bond the pump's base plate to the pedestal, the top surface of the pedestal should be either dry or wet, prior to pouring the grout. For epoxy grout, the surface should be dry. On the other hand, if cementitious grout is used, the surface should be kept wet for the period of time that is recommended by the manufacturer of the grout before grouting the base plate in place. Before installing the pump's base plate on the concrete platform, several steps need to be taken to prepare the base plate to be grouted in place. All equipment must first be removed from the base plate. This includes the pump, driver and any gear reducer between them. The bottom surface of the base plate should be thoroughly cleaned to ensure it is free of oil, grease and rust. The foot pads should be cleaned to remove any rust. A flat file can also be used to remove any burrs from the top surfaces of the foot pads, and to bevel their top edges. For metallic base plates, if the underside of the base plate is painted or rusted, the paint or rust must be ground or sandblasted away to reveal the base metal. All exposed metal surfaces that will be in contact with the grout must then be coated with a primer that is compatible with the grout that will be used. When using a hollow base plate, it can be advantageous to pre-grout the base plate prior to installation on the concrete platform. This can be done either at the manufacturer's shop or in the field prior to the installation of the base plate. Shown here is a welded steel base plate that is ready to be pre-grouted. Note the absence of top grouting holes and vent holes. When pre-grouting a base plate, grout is poured into it to fill the hollow part of the base plate. These are the main steps for pre-grouting a hollow base plate. If the base plate has grouting or venting holes, these must first be plugged if the base plate is to be pre-grouted. The base plate is then flipped over and supported in a leveled position. For metallic base plates, if the underside of the base plate was ground or sandblasted 8 hours or less before the application of the grout, no primer is necessary. Otherwise, primer should be applied to the clean metal before pre-grouting the base plate. The grout mixture is then prepared according to the recommendations of the grout manufacturer. Low shrinking grout should be used to minimize the distortion of the base plate as the grout cures and shrinks. The hollow part of the base plate is then completely filled with the grout using buckets or a grout hopper. The grout is then allowed to cure for at least 24 hours. In the next step, a thick plywood sheet is attached to the underside of the base plate in order to cover and protect the grouted surface. The plywood board is held in place by bolts that go through the base plate's anchor bolts holes. The plywood board can then be covered with a thick plastic sheet made of polyethylene or a similar material. The flatness, level and orientation of the various pump foot pads should then be checked. This is to ensure that the shrinkage of the grout has not resulted in excessive distortion of the baseplate. The recommended method for doing this check is using a coordinate measuring machine. Alternatively, targets can be set up on the four corners of each foot pad and an optical jig can be used to check the level of each optical target. If the distortion of the baseplate due to grout shrinkage is more than the recommended ranges of the baseplate's manufacturer, the foot pads must be remachined. The entire baseplate can be placed on a milling machine, and the surfaces of the foot pads can be milled back to within specifications. When the baseplate is ready to be installed, the plastic and plywood protective sheets should be removed prior to installation. Pre-grouting hollow baseplates offers many advantages. It reduces the installation cost of the baseplate since many labor hours required to manually fill the baseplate with grout through its grouting holes can be eliminated. This is due to the fact that it is much easier to fill the baseplate from its bottom than it is to fill it from its top. Since grouting can be done in an enclosed environment, better control can be maintained over the grout placement and curing processes. The ambient temperature, for example, can be precisely controlled in order to ensure proper curing conditions for the grout. There is no need to machine or cast in vent or grouting holes in the baseplate. For metallic baseplates, if grounding or sandblasting of the baseplate's bottom has been performed less than 8 hours prior to pre-grouting, then there is no need to use a primer on the underside of the plate. Pre-grouting minimizes the distortion concerns for the baseplate. This is due to the fact that even if distortion occurs, the condition can be easily corrected by taking the baseplate to a machine shop, and remachining the baseplate's foot pads on a milling machine. For baseplates that are not pre-grouted, however, in-field machining would be required to correct distortions of the baseplates beyond the recommended limits of the manufacturer. Since the baseplate is upside down during grouting, any air pockets between the baseplate and grout tend to float to the top of the grout. This minimizes void formation between the baseplate and grout, which is a common problem for hollow baseplates when they are installed without pre-grouting them first. The disadvantages of pre-grouting hollow baseplates include higher initial cost of the baseplate. This higher cost is offset, however, by lower installation costs. Pre-grouting the baseplate adds about 125 pounds per cubic foot of hollow baseplate volume that will be filled with grout. The lifting lugs of the baseplate must be designed to handle the extra weight. It is recommended to pre-grout the baseplate in a location that is close to where it will be installed. This is to avoid the higher shipping costs associated with transporting the much heavier pre-grouted baseplate. Finally, extra care must be taken when installing and handling the pre-grouted baseplate in order not to damage the grout.